$2.2 billion.
Yeah. It's a number that is genuinely hard to wrap your head around, isn't it?
It really is. And just to be completely clear for everyone listening right now, that isn't the GDP of a small nation.
Right.
That is the actual amount of value erased from the crypto ecosystem due to hacks in recent years. We are looking at the data today, and honestly, when you see a figure like that, the temptation is to just say, well, crypto is the Wild West, it's all gambling, and just walk away.
Which, I think is a completely fair reaction emotionally.
Mhm.
But it's also the wrong one if you actually want to understand where this technology is going. Because you can't fix what you refuse to look at.
Right. Hiding from the data doesn't fix the code. So today, we are doing a deep dive into the OWASP Smart Contract Top 10 for 2026. And before anyone tunes out thinking this is just some dry list of computer bugs.
It's not.
No, it's actually a fascinating psychological profile of how thieves are thinking right now.
That is a really great way to frame it. This report, which was released by the Open Web Application Security Project to help developers and auditors, it isn't just a theoretical list of complaints.
It's based on hard data, right?
Exactly. It's based on empirical findings, real security incidents and survey data collected all throughout 2025. It is essentially a map of the battlefield. It tells us exactly where the walls are crumbling.
And looking at this map, I mean, the terrain has changed drastically. We aren't talking about simple password guessing anymore. We aren't talking about a single developer just forgetting a semicolon.
Not at all. The underlying theme of this 2026 report is really complexity. The threat landscape has matured significantly. In the early days, say back in 2020 or 2021, you could rob a smart contract because someone made a simple typo. It was low-hanging fruit.
Just grab the money and run?
Yeah, but today, attackers are chaining vulnerabilities.
Chaining. Walk me through that, because that sounds like we've moved from a simple smash and grab to, like, Ocean's 11.
We really have. So chaining is where an attacker identifies 3 or 4 minor issues, things that individually might not even be considered critical risks by a security auditor.
Okay.
Like maybe there's a slight delay in a price update from an oracle, plus a function that allows a flash loan, plus a tiny governance lag.
And on their own, those are just, what, annoying quirks?
Right, just quirks, but together they form a kill chain.
So they're stacking exploits, like a combo move in a fighting game.
Exactly. They might use a flash loan to manipulate a price oracle, which then triggers some bad liquidation logic, which they then exploit to drain the entire vault. It's a highly coordinated sequence of events.
Wow.
And because of this new complexity, the OWASP rankings have shifted drastically this year. The list is organized differently now because the attacks themselves are organized differently.
Well, let's look at this leaderboard of destruction. I want to structure this by theme today, because otherwise it's just going to be a laundry list. So let's start with the front door. Even with all this new complex tech, the #1 spot, the absolute king of exploits for 2026, is still SC01, access control vulnerabilities.
The classic. It retains the crown.
It honestly feels almost disappointing that with all this advanced decentralized tech, the biggest problem is still effectively who has the keys.
It is deeply frustrating for the industry. But you have to remember, in the context of smart contracts, access control is subtle.
How so?
Well, it's not just, did you set a strong password? It's about function visibility. You have these incredibly powerful functions written into the code. Minting new tokens, withdrawing system fees, pausing the entire contract.
Or upgrading the logic itself.
Yes. And if a developer forgets to add a specific modifier, something like only owner, to just one of those functions,
then I can just call it.
anyone can call it. And we see this happen with terrifying frequency. A developer writes a function to initialize the contract, intending to call it once when they deploy it to set themselves as the admin.
Right, standard setup.
But they forget to protect it, or they don't call it in the exact same transaction. So an automated bot scans the blockchain, sees the open function, calls it first, and suddenly the bot is the owner of your protocol.
So it isn't even a hacker in a hoodie typing furiously in a dark room?
No, not at all.
It's an automated script, effectively walking up to the bank manager's desk, seeing the manager nameplate sitting on the chair, sitting down, and just saying, I'm the manager now.
And the bank just agrees.
Yeah.
And because the code is immutable, or at least designed to be rigid, once that transaction is mined into a block, it is law.
Wow.
That is why access control leads to full protocol compromise. You don't just lose one user's funds, you lose the entire system.
Okay, so that's the front door vulnerability. Lock the door, check the ID. But the one that really caught my eye in this report is #2. This feels like a massive shift in the meta. SC0 is Business Logic Vulnerabilities.
Yeah, this is the one that keeps me up at night. Back in 2025, this was much lower down. Now it has climbed all the way to number 2.
Help me distinguish this from a regular bug. Because if I have a business logic vulnerability, is my code actually broken?
That is the scary part. Technically,
Yeah.
no. Your code is doing exactly what you told it to do.
Really?
Yes. It compiles perfectly. There are 0 syntax errors. The failure isn't in the coding, it's in the design.
So the engineering is perfect, but the architecture itself is flawed.
Ideally, yes. Think about a decentralized lending platform. The code says if the user deposits 1 ETH, let them borrow 2,000 USDC.
Makes sense.
The code executes that trade perfectly every time. But what if the economic logic fails to account for a sudden liquidity crunch? Or what if the reward mechanism you build accidentally incentivizes a user to loop a transaction 50 times in one block to drain the rewards pool?
The infinite money glitch.
Precisely. It's like a vending machine where if you press refund and dispense at the exact same millisecond,
The machine gets confused.
right, and it gives you the soda and your dollar back. The machine isn't broken, the physical wiring is perfectly fine, but the logic of the state machine didn't account for that highly specific edge case.
And in DeFi, these aren't just sodas. These are automated market makers and lending pools holding millions of dollars.
Correct. And you can't just run a simple spell checker on economic theory. You have to deeply understand game theory.
You have to assume the worst.
You do. You have to ask, if I am a highly malicious actor with infinite money, how can I break this model?
That phrase right there, infinite money, that transitions us perfectly to the tools of the trade. The report groups SC03 and SC04 essentially as the weapons used to exploit these logic flaws. We are talking about price oracle manipulation and flash loans.
The dynamic duo. These two are responsible for some of the absolute largest drains we have seen in crypto history.
Let's start with oracles. I think most people getting into this space understand the concept. The blockchain doesn't magically know the price of Tesla stock or even Bitcoin. It needs a data feed.
Right. The blockchain is entirely blind to the outside world. It's a closed loop. An oracle is simply the messenger that brings that pricing data in.
So the vulnerability here is what? Shooting the messenger?
Or bribing it.
Okay.
If a DeFi protocol relies on just a single exchange to determine the price of an asset, say it's a small token with very low liquidity, an attacker can manipulate that one exchange.
By buying it all up.
Exactly. They buy up a massive ton of the asset to spike the price artificially, but just for one block, which is maybe 12 seconds.
And in those 12 seconds, they run over to the lending protocol,
which looks at the oracle, sees the wildly inflated price, and says, wow, your collateral is worth millions. Here, take this massive loan.
Oh, wow.
Then the attacker vanishes. They sell the asset back. The price crashes to its normal level, and the lending protocol is just left holding bad debt.
It creates a temporary reality distortion field for the smart contract.
Exactly. The contract completely thinks it is solvent, but it is basing all of its math on a lie.
But to pull that off, to spike the price of an asset across an entire exchange, even a small token, you need a lot of capital. You need to be able to move the market.
Which brings us to SC04, flash loans.
Yes, flash loans are entirely unique to blockchain. They allow you to borrow essentially an unlimited amount of capital. We are talking hundreds of millions of dollars, without any collateral whatsoever.
I always feel like I need to pause on this concept because it completely defies physics in the traditional banking world. You can borrow $100 million for 0 seconds.
For the duration of exactly one transaction execution. We call it atomic execution.
Atomic.
Yeah. In blockchain, a transaction is all or nothing. If you borrow the money, execute all your trades, and pay the loan back with a small fee by the very end of that single code block, the network says it's valid.
And if you can't pay it back,
The whole thing reverts.
it reverts. So it's literally like time travel.
In a way, yeah. If the payback fails, the network acts as if the loan never even happened. You just lose the tiny gas fees for the failed attempt.
But if it works, if you can pay it back, you have godlike financial power for that split second.
So flash loans are essentially leverage as a service.
They are the ultimate amplifier. Think about it. If you have a business logic flaw, like we talked about with SC02, that lets you steal 10 cents due to some weird rounding error, that's just annoying.
Right. Nobody cares about 10 cents.
But if you use a flash loan to multiply that exact same trade by $100 million, you have just stolen the entire treasury in one click.
It really highlights why the stakes are just so incredibly high here. We're building these open financial systems where absolutely anyone anywhere can grab a $100 million lever and pry at your weak spots.
That is a very vivid image, and it's entirely accurate. It removes the traditional barrier to entry for financial attacks.
Because you don't need to be rich to hack a protocol anymore.
No, you just need to be smart enough to write the flash loan contract.
I want to jump down the list to a newcomer. Rank number 10. This wasn't even on the list in previous years. SC10 is Proxy and Upgradeability vulnerabilities. What is this signaling to us?
This really signals that the industry is trying its best to grow up, but it's sort of tripping over its own feet in the process.
How so?
Well, the old crypto mantra was always code is law. You deploy it once, you can never ever change it.
Which sounds secure, but is terrifying for a real business.
Exactly. What if there's a critical bug? What if you need to add a feature to stay competitive? So developers started using proxies.
Give us the explain like I'm five breakdown on how a proxy works.
Okay, imagine a retail storefront. The physical street address never changes. Customers always know to go to 123 Main Street.
Got it.
But behind the scenes, the owner can completely change the inventory, the layout, even swap out the entire building structure that the front door leads to.
Okay.
The proxy is that storefront. The implementation contract is the actual building, so you can swap the building whenever you need to while keeping the exact same address for your users.
Which sounds incredibly smart. It allows you to patch bugs without forcing every single user to manually move their money to a brand new contract.
It is smart. It is completely necessary for mainstream adoption. But the vulnerability lies in the actual process of swapping that building.
Ah.
If the governance of that upgrade process is weak, say an attacker can somehow trick the proxy into pointing to their malicious building instead of your real one, they take over the entire application.
So I log into my normal bank, but the vault in the back has been swapped out for a black hole.
Exactly. Or, and this is actually very common, the initialization phase isn't protected.
What does that mean?
Many upgradable contracts need to be started up or initialized after they are deployed because of how the code structure works. If the developer doesn't do that in the exact same transaction as the deployment itself.
Don't tell me. An attacker can swoop in.
Yep. They swoop in, call initialize first, and set themselves as the owner before the real developer even gets a chance.
That is wild. It's literally like buying a house, but because you didn't turn your key in the lock fast enough, a squatter runs in and gets to keep it.
And legally, according to the code on the blockchain, it is their house now. That is the danger of SC10. It reflects this massive security debt we have taken on in exchange for flexibility.
We wanted to be able to fix our code, but the mechanism we built for fixing it has become a weapon.
Exactly.
Now, we've covered the high-level design stuff, the front door of access control, the economic engine of business logic and flash loans, and the governance trap of upgrades. But the report also lists the technical foundations. That's SC05 through SC09. These feel a bit like the, eat your vegetables part of security.
They absolutely are. These are the unsexy nuts and bolts coding errors that, frankly, shouldn't still be happening in 2026, but they are.
Let's group these together so we don't give everyone list fatigue. We have input validation, which is SC05, and unchecked external calls, SC06. This is basically just about not trusting strangers, right?
It's about basic data hygiene. SC05 is essentially garbage in, garbage out. If you don't rigorously check what a user is sending you, they might send a negative number where you expected a positive one.
Or a malicious string of code.
Right. You have to validate absolutely everything.
And SC06.
SC06 is about what happens when your contract talks to another contract.
Like a wire transfer.
Exactly like that. If you try to send ETH to a user and that transfer fails, maybe their wallet is blocked or it's a smart contract designed to reject it, you have to handle that failure gracefully.
And if you don't?
If your code just assumes the transfer worked and updates the internal ledger saying user paid, but the money never actually moved.
You've just created an insolvency event.
Yes.
Yeah.
You have literally created fake money out of thin air on your ledger.
Not ideal. Then we have the math traps. SCO is 7, arithmetic errors, and SCO9, integer overflow. Now, either computers are supposed to be good at math.
Computers are very good at math, but they are also very literal. Blockchains deal with fixed-size numbers.
Okay.
So if you have a digital container that can only hold up to the number 255, and you add 1 to it...
It doesn't just become 256.
Not always. In many older versions of Solidity, or if you are specifically using unchecked blocks in the code just to save on gas fees, it wraps around. It becomes 0.
Oh, wow.
Or significantly worse, if you have 0 and you subtract 1, it might wrap around backward to the maximum possible number in that container.
So I have literally $0 in my account, I withdraw $1, and suddenly the system thinks I have $1 trillion.
That is the classic integer underflow. Modern versions of the coding language do protect against this much better now, which is why it dropped a bit lower on the list. But it absolutely still happens in optimized code where developers turn off the safety rails to save money on transaction fees.
Saving pennies to lose millions. What about SCO7, the arithmetic and rounding errors?
That is the office space attack.
Yes, I love that analogy.
Right. In DeFi, you are constantly calculating interest rates or exchange rates for millions of dollars. If the math results in 100.9999 tokens and the system rounds down to
Wow,
100...
where did that fraction go?
Exactly. Someone is stealing the dust. If an attacker can manipulate the system to round down in their favor thousands and thousands of times in a row, they can drain significant value. It is literally death by 1,000 cuts.
One thing I noticed looking at this whole list is what isn't there anymore? Things like insecure randomness and denial of service are gone. Did we win? Are those officially solved?
Solved is a very strong word in this industry.
Fair enough.
I would say we have mitigated them or perhaps simply deprioritized them. We have much better tools now. Things like Chainlink, VRF, verifiable random function. So developers aren't trying to generate random numbers by just guessing based on block hashes anymore.
Which was always a terrible idea.
Terrible idea. And as for denial of service...
Yeah, why is that off the top 10?
Well, a denial of service attack is annoying. It freezes the contract. But does it actually let you steal the money? Usually not. And you have to remember, attackers are highly rational economic actors.
They're the ultimate capitalists.
They really are. They go where the ROI is the highest. Freezing a contract might let you hold it for ransom, maybe, but draining it via a flash loan and a business logic flaw is instant, guaranteed profit.
So right now, the highest ROI is in breaking the economics and the governance, not just clogging up the network.
Exactly.
So if you're listening to this, maybe you're a developer, maybe you're an investor, maybe you're just fascinated by where the tech is heading, it honestly feels a bit overwhelming. The ground is constantly shifting under our feet. We fix the math, they attack the logic. We fix the logic, they attack the upgrade process.
It can definitely feel that way. But that is exactly why the OWASP Smart Contract Security Initiative exists in the first place. This top 10 list isn't just supposed to be a horror story. It is a practical checklist.
It's a survival guide.
It really is. They have the smart contract weakness enumeration system. They have a massive detailed checklist for auditors. The overarching message here is you don't have to invent security from scratch. You don't have to just guess what might go wrong.
You just have to be humble enough to check your work against the list of people who have already failed.
Precisely.
Yeah.
And recognize that security isn't just a box you check at the very end of development. It has to be a mindset from day one.
Right.
You have to design the economics to be robust before you write a single line of code. You have to model the threats early.
That seems to be the big takeaway here for 2026. The landscape isn't about typos anymore. It is all about protocol-level design. It's business logic and upgrade governance.
Exactly. If you are putting your own money into a protocol, don't just ask, is the code audited? Ask who actually holds the keys, and does the underlying economic model hold up under extreme stress?
Which brings us to a bit of a philosophical edge to end on. I've been thinking about this as we've been talking through these exploits.
Sure. What's on your mind?
If the technical bugs are genuinely falling away, like randomness is fixed, overflows are handled by the compiler, and the logic bugs are taking over entirely, are we reaching a point where we can write completely perfect code, but we still can't build safe systems?
That is the ultimate question right now. We are building financial engines that are so complex, so interconnected, that maybe the human brain, or at least a single developer's brain, just can't fully anticipate the consequences of the rules they're writing.
We've mastered the syntax, but we've completely lost control of the semantics.
It is certainly something to chew on while you watch the markets. Are we building systems too complex to actually govern? The data from 2025 heavily suggests we might be.
Indeed. 2.2 billion reasons to chew on it. Thank you for walking us through the battlefield today.
It was my pleasure.
And to you listening, thanks for diving deep with us. Check your permissions, validate your inputs, and never trust an oracle you haven't verified. We will see you on the next one.